Hello and welcome to another Lunch and Code in this series where I spend an hour or so really learning about a new topic, and I use this time to help really set a specific period of time for me to learn about something new. In this session we're going to work on sponsored agents, which is something that I've really been thinking a lot about, and which is how an agent protocol might work for something like sponsoring these agents to provide responses. So it'll have sort of dynamics like an auction, bid requests, and some notions of robots.txt files. So there's a lot to unpack here, but we'll probably spend a little bit of time doing some planning, and then we'll try and run this process end to end and write some code to go through that process. All right, with that, let's jump in and start on some planning out with some requirements and what that might look like. All right, so we need to implement a agent-based bidding system for tokens. We need an example bidder. For a system that takes bidding the iPhone 11 and then bids out requests to AT&T, Best Buy, etc. Alright, let's see what this comes back with, and well, it comes I will work this out. Just didn't quite get that right, but there needs to be these items, so I'm going to need modularity with a dedicated agent, some bidding, some ranking logic in there too. Alright, so let's start, rename this to sponsored agents. Alright. Okay. So this is more like functional, non-functional requirements. I think we care more here about latency over completeness. So we want fast bid response from folks, from agents back in the chain. We probably want some performance based on the request response, e.g. complete within 200 milliseconds. Okay, then we can do some rough calculations. Oops. So if we say a bid request is 200 kilobytes average, let's see. There are 1 million queries a day. What type of system bandwidth, system or infra considerations do we need? Right, perfect. So network is going to be 200 gigs a day if we have 1 million requests. Requests. Egress costs. Some security stuff. Alright. I think ideally what we want to do is sort of build a functional demo as sort of the goal today. So let's put this as a goal, is to create a functional demo for sponsored agents. Alright, so yes, we have to think about the things that we need for this. I should put MVP. So we need this for MVP. Minimal ranking logic. I have some designs that I already worked on as I was sort of thinking through this. Yeah. A simple record product name, price, SKU, nice to haves. Alright, let's write this success criteria. Alright, so let's start mapping out some of these things. So we're going to say basic auction flow, we need user query. Why this is so small. Alright, we're going to have an agent request. Bid retrieval, and then ranking logic. And then last thing we need is some UI. I want to try and actually group these together. Alright, is there like a let's create a line here. Can I edit these? So we're going to consider there basically being 3 parts here. There's an agent request. We'll call this, and let's name these things. So this is going to be like a, what's the best way to decide it? LLM model provider, companion, copilot, whatever it may be, on this left side. And then we're going to have our, well, let's call this agents. We'll represent like 1 here, but like that will be there. And then this protocol we're going to call agents.json. So like a page like AT&T might have agents.json, and we'll come up with some representation schema for that soon. Ranking logic. So this is going to go like this. User sends request. It gets taken into a agent request. The ranking logic is going to be here. This is going to send a. I do not like these. These are all easier to see. And then the ranking logic will come back into the interface. This probably actually lives here. There's probably actually some more work that we're going to do between this bit. Okay. So, as I was looking at this, there was a paper that I found that I am going to try and dig up quickly. Alright, so this is the paper that has some mechanism that I would like to use. So I'm going to have the wonderful... so maybe I should go through this. So this basically proposes some auction mechanism for token-based bidding, but what it sort of turns back like this like response from the model. I think it uses BERT in the example. So I'm going to slightly adapt this. So instead of it might be a token auction model. We'll sort of see it where we get with it, but I think I don't really want the model to return a response that's like, so you can see it. So this is sort of what we're aiming to get to, is something like this. So the end state. All right. So at this paper, what I'm going to do is see if we can implement this paper. But rather than do the heavy lifting, I'm going to ask. Alright, so let's ask a question and try and implement this. The twist here are some requirements. Alright. Just going to read that document. Let's start by building oh, no, it's got it wrong again. Okay. they're bidding on the user. Like this. Perfect. Okay, let's copy this. I like it. And we can rev on it. Okay, so I think that we need to work on this agent.json. Take some inspiration from. Oh, you can't switch back. Huh. Take some inspiration from real-time bidding spec. See if we can find one. Whoa, this is old. This is dating me right now. How old are these things? 2 years ago? 2 weeks ago? Let's see. This is still a thing. Alright, so let's take the spec from three weeks ago, I guess. And let's give this to GPT. See what it comes up with. Huh. Right, I quite like this. Some things I quite want to take away, like, so I'm going to ask some more questions. So let's remove the precise location of the user from this. It's crazy. And then is there a way to implement more privacy so the query, the full query, isn't sent to the to these agents, just the information required. Okay, let's see this. Okay, this is super long. What does it actually say? Clio can do this, Clio can do that. But does it actually have any information about it? High-level insight that does not contain relevant or informative product. User query hashed. Whoa. A hashed encoded vector representation. Yeah, but that seems to be decoded. Okay, well, I'll just say, what about implementing something like the attached in the agent.json representation? I don't think it's really obfuscated by providing this. I like this, the categories. So let's take this and put it into oh, sick. Oh, so this is one iteration of what this would be. Okay, let's keep reading what. What is it called? Clio? Yeah. Instead of embeddings, it's intent entities, top level abstraction. I quite like that. Yeah, this is exactly what I want. It just means I'm going to have to add in another something else. Okay, so let's assume that the bid request is going to look like, the bid request format is going to look like this for the agent. So let's pull out another code block in here and assume that this is the code block that we're going to have. Okay. So this is what the agent's going to receive. Let's just call this agent bid request. Maybe there's like different entities here. So there's like, convert to this diagram. How does this know that this can handle these things? Like, it needs to like tell. There needs to be a tell before this. I'm not sure if I'm explaining this right. Let's write this down. So bid request is basically sort of like user intent, but there needs to be like something that happens. Bid request. So it's like user intent, and then like how does it select the agent? And that's where I'm getting to, is like maybe this isn't agents.json, this is like agent request protocol, and I need to actually work on agent request, or yeah. To write this down, but that makes sense. So like there's, in this chain, there needs to be like something that happens actually before this, which is some service is actually going to need to know, like, user, we'll call this like a publisher, but it's going to need to know, like, what are the agents out there. And that would be agents.json, and this would be like a agent request. Okay, so, but now that we have the agent request, maybe we can like reverse engineer part of this. Okay, so publisher need to figure out how to get figure out who to send these agent requests out to. How would we do that, and what might that protocol look like? Draw inspiration from robots.txt. Someone thought about this too. List of AI agents to block. What is in a... that just tells you what to crawl, which isn't that useful. Oh, cool. Agents discovery. Oh, sick. I like that. I don't love... oops. Don't like that it's Verizon, but sorry, not Verizon. No offense, Verizon. I don't like that it's in XML because I think it's harder for me to read, personally speaking, but maybe there's something here. So this would be the publisher crawls agents. The publisher maintains a database of known agents. It refreshes daily or hourly. The example would be like Best Buy, GDPR, and like the things that it signs up to sort of match by. Okay. Let me just ask. I like the agents discovery.xml, but can you change to JSON, please? Also think through function calling. From this is this might be the mechanism to choose the appropriate agent to call. All right. Publisher fetches the name. Didn't they do something like this though? They did like a function calling API or something like that. They did OpenAI function. What was it called? It was called like tools or something. I don't remember what it was. I know it didn't have bidding in, so interesting. Anyway, let's look. So it's saying this file is hosted by each agent. Okay, so this just like implements just like agent discovery. So this is saying the type is a function, selects agents based on their bid request, category, and intent. Okay, let's say provide me with an example of agents discovery.json. Oh, sick. It could add authentication into. I like this. Well, the problem here though is that this is for like assume there is only one advertiser per agent for the example, e.g. Verizon has their own agent and Best Buy has their own too, e.g. verizon.com/agent. Okay, so I think we got an idea about what we want this to look like now, which is cool. Let's go back here. Add a code block in for this. So we'll probably name this agents.json. Okay. To make this simpler, so agent.json, this would be like a request protocol that would come after this, so like these two would join together. What would be an agent response to this? No, they respond with the tokens and a bid per token. And whether it's sponsored or not. So you can put another code block in here. agent response.json. So let's copy a logo from here just to take T-Mobile if I can. Okay. Well, let's pixelate it. Okay, so this would be like T-Mobile's response. This would be like T-Mobile's agents.json. This agent protocol would come from a provider like OpenAI. Oh, they changed all their all of their designs. Sorry, OpenAI. Okay, I think you get the idea. And then this instance, like, to maybe just make this full circle, is this notion of agents.json, the list on every website. So like multiple websites have agents.json files. Each day, those JSON get picked up by the major destroyer, be it they don't even be major, they could be majors and minors. I guess maybe the agents don't care. I have so many questions, but like what's going through my head now is how would they know whether it's a bid request? How would they know whether the bid requests are from the right people? But like, let's assume that these agents are all being picked up by these distributors. These distributors have users. User one. Square. Okay. User one. User two. User three. There has to be a better way to do this. I think, yeah, whoa. You get the idea of what we're doing. These obviously have links to each of these folks. And then each of these different distributors have different users. They log into the platform. So the distributor platform. E.g. LedChat. Okay, you get the idea. They go through the distributor platform. These users then make queries, e.g. have a conversation with a bot. Maybe there's some user control. They determine whether bid requests get sent out. Then if agent on, it will then use its own LLM or whatever it may be. If the agents are on, then we will orchestrate an agent request. Then from the agent request, we'll orchestrate an agent request, select the appropriate agents for the task. Then once we've selected the right agent for a task, send out bid or agent requests to agents. Evaluate. Respond with bids. Review the and evaluate the bids and select the appropriate sponsored agent, and then from that sponsored agent show the sponsored agent result. Alright, that sounds crazy long, but that's like basically the MVP right here. We're not going to do crawling and that other stuff, but just like trying to get this chain in a easy to way. So maybe I'll, so each of these companies like T-Mobile and others will have an agents.json file. The agents.json file will represent like what they care about that we highlighted right here. So I'll say like, oh, my agent is Verizon Ads. Here's a descriptor. Here's the supported things that I care about. Here's my supported intents. It supports token bidding. Says some privacy things. Has some rate limits for the providers. Provides some authentication, assuming that the platforms could do that. That's then stored in a database with the major distributors. So the major distributors will have this, let's call it, they'll have like a database DB of agents. Okay, then a user uses that platform. They make queries in the platform, have a conversation. If the user has their agents enabled, it will continue. If they don't, it just uses the standard form. If the agent's turned on, it'll orchestrate an agent request that we had. That's a response. An agent response as we listed here. There's then some selection of the agent of the. Oh, sorry. It then needs to figure out somewhere in between here which agent to use. It'll send out that request for agents. Then the agents will respond with a request. Then we'll with the response, and then they'll figure it out. Okay. Give a good idea of the work to do. Let's Okay, so we spent basically we spent a good amount of time doing some planning here. So I think maybe let's spend like let's start by implementing some of this stuff. Alright, now let me open up VS Code and move some stuff around. I want to do most of this in Python. So let's open up a new window. Terminal. Sponsored agents. How do I copy this? VS. Whoa. It might actually be better for me to share my entire screen. Let's move OBS out and try and get this screen. All right. Okay, so let's start by building agent crawler.py. Okay, let's work. Okay. Mission we have a we have agents.text files for Verizon, TNT, etc. in the following format. Didn't connect this. Oops. Okay. Okay. use typing. Alright, so I'm going to say we're going to have this thing called, oops. So this is a file that will handle agent crawling. Okay, perfect. Verizon. Let's see if this works. Oops, I don't know why. Agent crawler. Loaded 2 agents successfully. Okay, perfect. So a crawler now that will return these agents. The next thing I need to do, let's look at the diagram. So if we have, I'm going to mark this in colors so I know what I've actually done. Okay. Let's make this green. So we have like 2 agents. Let's put one more in so I can say that I've done this. Okay. Come up with another agent called apple.text and let's say 5 others. So that's Apple, let's put Amazon in here. Ooh, Samsung, that's an interesting one. Target in. This should probably be JSON, but it probably means to do some reasoning about why they were called robots.txt. Alright, there's AT&T. Let's make sure that this worked. Okay, so it's got all of these things. Okay. Now let's. Okay, what's next in our thing? Okay. Okay. We are a distributor sending out these bid requests to these services. Using Llama. should then create a bid request in the following format to set. Then the agents, then there needs to be some logic in selecting the appropriate agent, and then send those requests to an agent. They should respond in the following format. Where is it? In this format. With that format, then there should be some ranking logic to show something. Sponsored agent content to the user. Okay. Let's see what it comes back with. Send bid requests out. I'm going to simulate the endpoints, but we'll do that later. There was one method in here which was Ollama chat references. Oh, here we go. Is this long? Let's see. Okay, so this actually does do this, but it's like super long. So I'm going to see. Actually, let's just try it. It's actually not that bad. Let's see. Agent examples. Pip install. Check Ollama's working. Mistral model, try pulling it first. Okay, so I have to pull that model. Alright, we'll wait for this to work.
first. I'll be still streaming.
Cool. Okay, let's see if this now works. Python 3, import llama, user query, the request. How does it do this? Like, I'm just curious now. Let's just give it this.
Alright, okay, so it's got that, so then I need to just do ollama extract entities. Okay, I don't think this is right. Yeah, if these are queries this, I'm just going to say ollama let's change this. I think this may need some work. Let's get out of this. Doesn't respond. Okay, why is that? Oh, well, I get something out of it. What about themes? I don't know how this conjures up a bid request. Okay. Let's just do an entity extraction, which I think is fine. I don't know how I feel about it. Long story. Just a. Let's just say I want to generate. Can you change the script so that Mistral is generating the category I have a different question, but I'm just like this intent might need to be ignored to start with.
All right. This definitely needs some more work. So we have some basic distribution. What I need to do right now is run assume that we are not going to run these requests. Externally, can you come up with a sample beta? A sample agent .py that receives bid requests and returns bid responses. So this assumes that this receives an ad. I need to install Flask. Actually, let's use fast. What's it called? Whoa, what the hell just happened? Okay, so I can give it a bid request and see what happens. And send a response. That's pretty cool. Okay. Can you alter? Let's see. Maybe I can change it. I'm going to change the distributor now to, instead of generate bid request item, return bid request alarm or extract honesty, product comparison, the intent, session ID, select the bidder, send the bid request. Okay, so instead of sending the bid request, we're going to just decide to take this out, and we're going to send it to this local. Whoa, wait, it supports docs too. That's crazy good. Wow. That's awesome. Did not know it did that. Huh. That is a cool feature. Huh. Nice job, whoever did that. Okay, so I'm curling requested this. Okay, now let's see what happens when I run the distributor and take this out and just say process user query. This should. Okay, so maybe I'll just pause here before we run this. So we are now in this situation where we have these agents.json files. These are actually here. I call them text. They should probably be called JSON files, but for the purpose of today, I think it's needed. Okay, so we make requests here. This is an example on this side as what do I call it? Oops. Compare iPhone prices. And this then. And this is the second part. So we managed to we just tested a curl command to do this orchestrate agent request. What we're going to do now is try and run this to send out the agent and get the bid requests back. Sort of where we're at. Go with status. I mean, I can make it huge, but it's not. It just makes no sense. Alright. Okay, let's run the distributor. Examples not found because I changed the name. Okay, sweet. So it got a bunch of responses. Matched agents, Best Buy, Walmart. I think you got all of them. It finally ranked the bids. These are all Verizon. Because I guess the bidder just is a static bid. Yeah, so it's just for the iPhone basically. Let's try and change this so it's like more dynamic. So we got a bid request back, which is sweet. It just seems like the we'll probably just like, this isn't really a good example. It'd be better if there was like just two bidders that had different products, so you can sort of see this more easily. So let's maybe change this. Let's go ahead and change the agent.py to represent two different buyers, AT&T and who did I have in my example? So let's make sure we are really covering use cases. Who do I have here? Best Buy.
Best
Buy and AT&T. Best Buy should win the auction. So it should show. The AT&T text. Let's get back our agent that we are going to change to here. Alright, oh, this should work now because it should handle the bid request. It comes in, let's get the terminal, turn off this agent, turn it back on. If I run this, I should see that. No, just all I get back is Best Buy, Best Buy, Best Buy, Best Buy. That is so odd. Okay. Okay. Alright, okay, so we got an updated version of Agent. And we have an updated version of Distributors. Send bid request. That's going to be difficult. Let's see. Does it just return the response? This generates a bid request. That's static, so I'm not going to do that. this works. I think it repeats it because it has so many, but I'm just trying to figure out how to, like, instead of sending it to all, maybe I can just send it to the... No, you've shortened the distributor.py file. Please fix this. Okay. Okay, let's try this distributor. Okay, let's change the bid request. Okay, so the final right bid is only returns one. Multiple bids in the list. Okay, perfect. This is going to send multiple bids back. Right, so that's running distributor. And now we have our two things, our two bids returned, which is pretty cool. So maybe just to recap what we did, what we've done is let's go back here. Firstly, we created this agents.json object that sort of represents the mechanism by which these companies can provide an agent schema to use. With that agent schema, it then loads into a platform distribution. We're using distributor.py here as an example of that. So if a user type compare iPhone prices, it would then look up all of its agents and then respond. So it looks up all these agents and then sends bid requests out. So that bid request or agent request looks something like this. It has intent, entities, categories, context, and privacy level in here. The reason for that is you probably don't want the entire raw data being sent, so we use Clio to try and process that as a mechanism potentially for us to aggregate content. And then with that, with the request, there's also a series of responses. So we have the an ID for this individual impression, a price per token, the tokens allocated, the tokens that are returned, the advertiser, and then whether it was sponsored or not. Yeah, and then we just went through this workflow. So yeah, pretty cool. Yeah, I will I think I'll leave it at that. This was a fun exercise of just like going through this process. All right, bye.